Another part of section 9.4 is the discriminant. Okay, the discriminant covers standards 20.0 and 22.0. And the discriminant is the portion of the quadratic formula that is underneath the square root sign. So you have the discriminant equal to b squared minus 4ac. It's only that small portion of that formula. But it tells you a lot of information. What it tells you is the number of real roots that quadratic equation will have. Okay, so by number of real roots, it basically tells you the number of times that graph is going to intersect the x-axis. Okay, so let's detail out exactly what information it will tell you. Okay, once you find the value of the discriminant, your answer, the value of that discriminant, could either be 0, it could be a negative number, or it could be a positive number. Okay, if it is a negative number, this means that you have no roots, 0 roots. It means that it does not intersect the x-axis at all. Okay, if you have a value of 0 for the discriminant, it tells you that you're going to have double of the same root, which really means your root could be x equals 3 and x equals 3, which means you really only have one point of intersection. Okay, or you can have a positive value for your discriminant, which means you'll end up with 2 roots, or 2 places on that graph where your graph will intersect the x-axis. Okay, so let's draw this out so that you can visualize what I'm talking about here. Okay, in the first, no roots. Notice in this example, okay, here's your x-axis. Your graph does not touch the x-axis at all. Okay, so that's what we mean by having no roots. Okay, so this occurs whenever the value of your discriminant is a negative number. If the value of your discriminant is 0, then this means that you're going to have the same root, but double of the same, meaning it may be x equals 3 and x equals 3, which means it only really touches the x-axis at one point. They call it a double root, but it's the double of solution of the same value. Okay, so positive means you have 2 different roots. Okay, and I'll actually write that in. 2 different roots. Okay, so it's 2 different places on the x-axis where your graph could intersect the x-axis. Okay, so let's say it may look something like this. Okay, so it either has 0 roots, it has 1 double root, or it has 2 different roots. Okay, so just an example for you. Let's take a look at this question here. We want to find the value of the discriminant, and we want to find the number of roots. So for this example 1, keep in mind that discriminant is equal to, I'll just write g for discriminant is equal to b squared minus 4ac. Okay, so let's see what our a is. A is 1 in this case. There's an invisible 1 there. B is 3, positive 3. And C here is a negative 4. Okay, so if we plug everything in for the value of a discriminant, and I'm just going to name it D, let's say b squared, so that's 3 squared, minus 4. A is 1, and C is negative 4. Okay, so D will equal to 3 squared, which is 9. A negative times a negative will give us a positive. 4 times 4 is 16. So 9 plus 16 will give us 25, which is a positive number, right? We're going to write this as a positive value. Okay, and what we said before, when it is a positive value, look back in your chart here, when it is a positive value, you're going to have 2 roots. Okay, so since it is a positive value, you're going to have 2 roots. Okay, and what you can do, and you can take this a little further, is you can actually factor out and determine what those 2 roots are. Okay, so let's take a look, let's go back and see if we can quickly factor it out and determine our roots. This looks like something that we can factor out. Okay, we can do the x for this. You have -4 and a +3, so it looks like 4 and a -1. So x plus 4, x minus 1 is equal to 0, and we can use a zero product property, so x will be equal to a -4 or a +1. Okay, so if we were to actually sketch out this graph, and you don't have to do this yet, but just to give you an idea, here's your rough sketch. Here's the x-axis, here's the y-axis, so you know that it will intersect the x-axis at -4, so 1, 2, 3, 4, and it will also intersect the x-axis at 1. So maybe, well, we'll just sketch. It could look something like this. Okay. I'd like for you to try this right here. Okay, bring it in tomorrow and we'll talk about it. Again, you're looking for the discriminant and the number of roots. Okay. So let's try with this example here. Okay. Again, our discriminant is equal to b squared minus 4ac. Keep that in mind. But we're looking, right now we cannot determine what a, b, and c is. It has to be in the standard quadratic equation form. So which means we need everything over to one side set equal to 0. So we're going to subtract 1/2 r, subtract 1/2 r here. We're going to add 2/3, add 2/3 here. Okay, so what you'll have is 2r squared minus 1/2 r plus 2/3 equal to 0. You can only extract the values of a, b, and c in this form. Okay, so it has to be in this form here for you to determine a equals 2, b equals -1/2, and c is equal to 2/3. Okay, so there you go. We're going to use these values to substitute in. Our discriminant is equal to b squared, so that's -1/2 squared minus 4 times a times c, which is 2/3. Okay, -1/2 squared, well that's -1/2 times -1/2, which give us a positive 1/4. Okay, minus, here's 8, and going to be 8 over 1, 8, so that'd be 16/3. And our discriminant will be the value once we find our common denominator, because we're subtracting, we need common denominators, and it looks like it'll be 12. So that means I need to multiply this side by 4 over 4. I need to multiply this side by 3 over 3 so that we have a common denominator. So this will give you 3 minus, let's see, 64 all over 12. Okay, so that's a -61 over 12. This is, our discriminant is a negative number. It is negative. Okay, when it is negative, go ahead and flip back if you don't remember yet. Negative means there are 0 roots. Okay, so we can go ahead and express that there are 0 roots. Okay, and if you wanted to use the quadratic equation, quadratic formula to find out exactly what the roots are, you would come out with the same information, that there are no roots. Okay, so give this one a try and bring it in tomorrow and we will talk about it.